Night hangs over a frozen test range outside Moscow. Floodlights wash the snow in harsh white, and diesel breath rises from a machine that looks less like a tank and more like something fallen from orbit. Its hull is an oval, smooth, cast, and flattened, perched on 4 continuous tracks that wrap it like a steel sled. The engine note swells. The snowpack collapses under the weight that should break it, yet the monster glides forward. A plume of powder trails it. The wind dies. Silence returns. Someone clicks a Geiger counter. The needle flutters. The needle flutters. The crew seals the hatches. This is Object 279, an experiment born in 1957, shaped by the memory of a war that had ended only a dozen years before, and by a new fear that had arrived almost immediately after. A battlefield lit not by flares or tracer fire, but by the white dome of a nuclear blast. To understand why Soviet engineers built a tank for the aftermath of a nuclear strike, we need to walk back from that floodlit might to the foundries and drafting rooms where the tank's shape was imagined. The Second World War never left those buildings. The Kirov Plant in Leningrad, besieged, bombarded, and stubbornly productive throughout the war, had produced the KV heavy tanks, and then the IS series that smashed through fortified German positions from 1943 to 1945. Welders who had worked by candlelight during air raids, designers who had sketched around crater holes in their drafting tables, many of them were still at their benches in the 1950s. They remembered the Eastern Front, rivers of mud that swallowed road wheels, snow that turned oil to glue, artillery that cut tank brigades into burning islands. They remembered what saved crews and what killed them. From those memories came design habits, heavy frontal armor, sloped plate, wide tracks that would carry into the post-war decades. But the battlefield was changing. Early in the 1950s, both superpowers tested nuclear devices in the kiloton and megaton ranges, then tried to answer a brutal question. If war came, could armored forces survive long enough to fight? Blast waves flip tanks. Thermal pulses ignite external fuel drums and rubber. Radiation contaminates dust and water. A tank that could move through that chaos, over cratered ground, past toppled trees, under rain seeded with fallout, would not win a nuclear war, but it might give a commander a tool when all other tools had broken. So the Leningrad Kirov Design Bureau, with heavy tank experience rooted in wartime production, set to work. Their brief: stability and mobility under nuclear effects, armor that could resist shaped charges, and new high-velocity rounds, and a gun that could overmatch whatever enemy armor might survive. The result looked unlike any other tank on Earth. Object 279's hull was a great cast ellipsoid. No long flat plates to catch the fist of a blast wave. No high corners to present target angles to armor-piercing shot. The contours were deliberate. An overpressure front, like a hand sweeping the ground, would be more likely to flow around that curved body rather than grip it and roll it. The hull sides flared into smooth skirts that covered 4 separate track runs, 2 on each side. 4 tracks were not an eccentric flourish. They were a calculated answer to two problems at once. First, ground pressure. Spreading more than 60 tons over that many contact patches lowered the pressure on mud, snow, and ash so far that contemporary testers recorded ground pressure figures more typical of much smaller vehicles. Second, survival. If one or even two track runs were damaged by debris or a mine, the remaining drives could, in theory, keep the tank mobile. The layout created a kind of armored sledge, in which the hull rode above the nastiest part of the terrain, while the tracks carved a broad, stable path. Inside, engineers installed systems aimed squarely at nuclear, biological, and chemical threats. The hull was hermetically sealed. An overpressure system, a fan and filtration train, would keep contaminated air out by maintaining a higher pressure inside than outside. Early reports indicate the use of specialized internal coatings and linings to reduce radiation penetration and to guard the crew from spall and heat. Precise material specifications vary by source. Some describe anti-radiation treatments and spall liners, others emphasize the sealing and ventilation as the core defense. Contested, exact composition and thickness of anti-radiation layers, which likely evolved during testing and are not fully declassified. The crew compartment itself followed the wartime lesson that survivability is not just metal thickness, but layout. Fuel and ammunition placement tried to balance accessibility with protection, and automatic fire suppression systems stood ready to flood the hull and engine bay at the first tongue of flame. And then, there was the gun. Where Western main battle tank concepts were converging on 105mm smooth and rifled pieces, Object 279 carried a larger, more powerful weapon, a 130mm rifled gun commonly identified as the M65. It was an artillery-grade piece adapted to armored combat, with a long barrel, stabilization for firing on the move, and a loading aid, variously described as an assisted loading system or an autoloader, intended to tame the weight of the shells. The intent was brutally simple. If any armored vehicle survived the apocalypse, Object 279 should be able to kill it. This gun choice was not a bolt from the blue. Soviet wartime experience with heavy assault guns and tanks, KV-2s lobbing massive shells at bunkers, ISU series guns cracking heavy armor, had given designers an instinct for big-bore guns when the mission was decisive. The post-war decades saw that instinct refined by better ballistics and more compact recoil systems, but the principle remained: end the fight with the first hit. Several performance figures illustrate the ambition behind the turret. Penetration claims vary across publications, a red flag for historians. But contemporary test data agree that the 130mm round family offered formidable armor-piercing capability at typical combat ranges of the 1950s. Estimated. Exact penetration values depend on projectile type and test standard. Soviet and NATO methodologies differed. To swing that turret and push those tracks, Object 279 needed power. Here, the designers faced the classic heavy tank problem: how to move a land battleship without devouring the drivetrain. Surviving documents and museum notes point to a multi-bank diesel producing around 1,000 horsepower, often identified as the 2DG-8M, a compact, high-output unit mated to a hydromechanical transmission. Contested, exact engine variant and power output. Some sources list closely related designations and incremental power figures during trials. On hard ground, the test vehicle reached road speeds near 50 kilometers per hour, remarkable for the era and mass. Off-road, the 4-track layout preserved traction where twin-track contemporaries bogged. The tank's shape and systems tell one story. The way it was tested tells another. Footage and reports from trials conducted in the late 1950s, including at the Kubinka Proving Ground west of Moscow, show the machine doing what it was built to do: crossing soft ground and artificial obstacles, climbing steep ramps, and traversing trenches that would pitch a conventional chassis forward onto its nose. The 4-track carriage held the hull level where others tilted. The elliptical armor shrugged off the violence of sudden drops. Engineers evaluated more than mobility. Blast simulations, overpressure calculations, and practical tests with high explosives assessed whether the hull would flip or the suspension would shear under shock. The oval form, the low profile, and the mass distribution worked toward a threshold: survive the wave. There were limits, of course. No tactical vehicle could remain combat-capable inside the lethal radii of a large nuclear detonation. The aim was to operate at militarily relevant distances from ground zero, where units scattered across a front might be damaged but still able to fight. Within that range, the tank had to protect its crew from dust-borne fallout, spare them the worst external dose, and keep moving. The results were promising, but the battlefield was no longer only a battlefield. It was also politics. By 1958 and 1959, the Soviet leadership, driven by the rocket force's rise and by Nikita Khrushchev's faith in missiles over heavy armor, began to starve heavy tank programs. Object 279 was not alone in the crosshairs. Its contemporaries, Object 277, Object 770, were also large-caliber, high-protection machines born of similar logic. All of them ran into a wall, a policy shift that de-emphasized heavy tanks as relics of the last war. In 1960, a government decision effectively halted the development of heavy tanks and heavy self-propelled guns. The move was grounded in doctrine. Faster, lighter, missile-armed forces were the future, and in budget. There is debate among historians about the fine-grained of the decision. Which memos, which committee arguments, which trials were used as evidence for or against. Contested, the precise text and numbering of the decree referenced in many secondary sources. The substance, termination of heavy tank development, is not in dispute. Regardless, the effect is clear. The Object 279 project stopped. According to museum records and recollections from the Design Bureau, only one prototype was completed and put through comprehensive trials. Some sources suggest additional hulls or partial assemblies were in progress. None entered service. The finished prototype survived long enough to become a museum piece. Today, you can walk around it in Kubinka, now part of the Patriot Park complex. Run a glove across the armor's cold curve and peer at the strange spider leg tracks tucked underneath. What does this artifact tell us? On the surface, it is a closed chapter, a talented team chasing a dead doctrine. Look closer, and you see a lineage, from the steel hammers of the war years to a nuclear-age instrument, threaded by 3 ideas that the Second World War had burned into Soviet engineering. First, stabilize the gun and the platform. The Red Army learned on the Eastern Front that a hit at the right time when mud and smoke were thick and orders thin, could break an attack or save a retreat. That meant a gun as accurate as the crew that served it, and a chassis that could move and still deliver steel on target. Object 279's heavy stabilized weapon and four-track carriage were logic-driven to a maximum. Second, protect the crew with shape and system, not just thickness. War taught cruel lessons about overmatching weapons. Angling and shaping could double the effective protection. Sealing and overpressure could sustain men in air that would otherwise kill them. The nuclear layer on top, filters, detectors, a hermetic hull, was new. The principles were not. Third, keep moving. Soviet tanks had survived in 1941 and 1942 in part because they kept moving when roads turned to rivers or the sky rained metal. Engineers who had watched T-34s churn through the spring thaw kept that lesson alive. The four-track solution for Object 279 was a radical way to widen the footprint and preserve traction. It would show up in different forms in later decades, in wide tracks, in engineering vehicles, in experiments that never left the yard, but the instinct behind it remained part of the design culture. These continuities are not national myth. They are workplace memory. The men and women who built and tested Object 279 carried the wartime echo with them. When they ran their hands along the cast hull, they knew what spall feels like. When they laced the interior with cables and extinguishers, they remembered fires that flashed from a single spark to a hull-wide storm. When they tested an NBC seal, they recalled how smoke and gas killed faster than a bullet. The tank is a machine, yes. It is also a record of what those people had learned. There is another way to read Object 279, one that has less to do with victory and more to do with fear. A nuclear survivable tank embodies a contradiction. It assumes the unthinkable has happened, and then asks, what next? It tries to imagine command and control when radios are jammed by ionized air. Logistics when roads are crater strings. Navigation when landmarks are gone. The heavy turret suggests an enemy that still resists. The NBC systems assume a crew that can endure longer than the dust cloud's half-life. It is a machine designed to work in the smear between catastrophe and order, at the moment when soldiers expect orders and commanders have none to give. In that sense, Object 279 is less a weapon than a symptom. It is what planners build when they are sure war will shatter everything they understand about war, and they are not willing to surrender the battlefield to that shattering. Yet the battlefield did not unfold the way its designers imagined. The Soviet Army did not ride across a nuclear-blasted northern European plain. Instead, tanks evolved toward a single category, the main battle tank, which blended the mobility of a medium with the firepower of a heavy. In the Soviet case, the T-62, T-64, T-72, and T-80 series carried forward many lessons: stabilized guns, composite and reactive armor, NBC protection, without the weight and complexity of a four-track nuclear sled. Advances in ammunition and armor changed the trade space. Changes in doctrine tilted away from massive penetrations by tank armies toward combined arms centered around faster, more easily supported vehicles. Missiles, both anti-tank and surface-to-surface, reshaped the armored battlefield. What survives of Object 279 is therefore both singular and instructive. It reminds us that technology is shaped not only by what engineers can do, but by what strategists believe they might have to do. Walk around the prototype. Stand by the left front corner and trace the arc of the glacis with your eye. Imagine a blast wave pushing across it. Imagine the force sliding instead of grabbing. Duck down and look beneath the skirts. 4 track runs, each with its own suspension, idlers, and return rollers. Maintenance crews would have cursed those systems. Mobility crews would have blessed them. Climb the mental ladder to the turret ring. Picture the breech of the 130mm gun swallowing a shell whose weight you can feel in your shoulders. Think of the loader's hands, the automation's whir and clank, the recoil clouding the air inside the sealed hull. Then listen for the softest sound, the fan in the NBC system spinning to change the pressure by a fraction, making the difference between a safe breath and a dangerous one. Now shift the frame. See the men in gray coats with grease on their cuffs, arguing over torque and temperature in a winter test shed. Hear the blunt assessments in trial reports. Mobility, excellent. Maintenance, complex. Survivability, improved under specific conditions. Watch the politics move. Budgets cut, priorities rewritten, projects stopped. The tank remains, heavy and silent, an answer to a question history did not end up asking. But history did ask other questions, and Object 279, though it did not serve, nudged the answers. The emphasis on crew protection fed into later developments of overpressure and filtration systems that became standard. The lessons about blast effects on armored shapes informed not only tank armor, but also fortification and vehicle design across the Warsaw Pact. The push for big, stabilized guns accelerated work on fire control systems and range finding that became essential in later main battle tanks. Even the failure, too heavy, too complicated, too specialized, was a lesson engineers carried forward. The best tank is the one commanders can supply, crews can maintain, and armies can use across missions. What remains contested should be said clearly. Exact penetration tables for the M65 vary with test methods and projectile types. Different archives preserve different numbers, and some of those numbers were classified for decades. The precise internal layering of anti-radiation materials is likewise difficult to certify without full access to factory records. Standard Soviet practice included protective linings and overpressure, but the thickness and composition in this prototype likely changed during trials. Engine designation and output, commonly cited around 1,000 horsepower, appear in several forms, which may reflect incremental upgrades or simply the way different documents label the same unit. None of these uncertainties changes the tank's essential character. They are the normal noise of historical engineering research, especially when dealing with a single prototype from a secretive period. What is not contested is the tank's reality. It was built, it ran, it was tested, it did not enter service. It survives. Return, finally, to the scene we began with, the floodlit snow, the diesel plume. the tank moving where it should not be able to move. Imagine, just for a second, that the light over that range is not electricity, but the edge of a distant detonation. The crew inside does what crews have always done. They check gauges. They listen to their machine. They talk in clipped sentences. And they go forward because the map says forward, and the order was to advance. The oval hull shoulders the wind. The tracks bite. The fan hums. Somewhere beyond the horizon, the war that made this machine possible has ended, and the war that would have justified it has not come. In that narrow space between memory and fear, Object 279 exists, a machine from an alternate future engineered by people who had survived one catastrophe and were trying, in their way, to imagine another. Walk away from it and you carry two impressions. The first is of audacity, a willingness to rethink even the fundamental geometry of a tank to meet a new threat. The second is of restraint, a recognition, implicit in its cancellation, that not every audacious idea belongs in the force. Both are products of the same history, the bitter, inventive, deeply human history that ran from the factories of the Second World War into the laboratories of the atomic age. In the end, Object 279 is best understood not as a failed tank, but as a successful question. What happens to armor after the bomb? The answers: curved hulls, 4 tracks, sealed lives, tell us as much about the people who asked as they do about the world they feared. And if we listen closely to the machine itself, with its strange lines and muted promises, we hear not only the Cold War speaking, but the echo of the Eastern Front, the place where Soviet tank design learned to endure, and from which even the most exotic future could not escape.